So once you've got the output from your program, we need to be able to analyze it to answer those questions. And the easiest way to analyze it that I've found is probably putting the memory locations into Excel, because it's just got that grid format for us. So I'm going to highlight the section that I need, and to be able to do that highlighting in the command window, I have to click on Edit and then Mark, and I'm just going to highlight this section at the moment. So then to copy it, you either press Enter on your keyboard or you go back up to Edit and click Copy, and then I'm just going to go into Excel and paste that information. Now luckily for me, when I printed everything, I put a colon in between the sentence and the memory address, so I should be able to separate out the memory address into a separate column by itself. And for that I need to get the Data tab, and then there's a Text to Columns option there, and in that option you need to select Delimited, because that's basically saying tell me which character you want me to separate out the data at, and choose Next. I don't know which ones are normally ticked here, but the one that I want, the colon isn't, so I'm going to click Other and then type colon in this box, and straight away it's recognized that that's the colon and it's separated out everything else. I'm then just going to go to Next and Finish. I now have my memory addresses separated out. Now I think what's happening is this is being treated like a number because it had a 4 in front of it, but these I think have probably got a space in front of them and leading zeros, so it's not really treating this as a number. It's treating it like text, and it may not happen. It kind of depends on what memory addresses you've got on your computer, but I want to convert these into just decimal numbers so that I can do something with it. So I can choose that formula equals hex to dec, this one here. This is the number I want to convert. It's probably going to give me an error. Yes, it does, because I need to remove these leading spaces. Anyway, if it does that for you, then you know what the problem is. We need to remove the leading spaces in front so that it will treat it like a number. And what this has basically done is we got the memory address as a hexadecimal location, and what we've done here is we've just converted it into a decimal number so that it's easier for us to deal with. Now once we've got these numbers, these are still really big numbers. I'm just going to pick up the main function and just move it out of the way for a minute and just deal with these here. In fact, I can just drag these over the top too. Okay, so now what have we got? We've got, the numbers at the end are changing. So I've got 20, 24, 28, 35, 36 and 48. So I can actually not have to worry about the bigger numbers. So let's just imagine that we've got very small amounts of memory, and we haven't got those thousands or hundreds of thousands in front. Now, what is it exactly? Hundreds, thousands, tens of thousands. Oh yeah, it has got hundreds of thousands. Sorry, just going off track there a minute. 48. Okay, so you can also use the mod function here anyway, however you want to. But these are the numbers which are much more straightforward for human beings to comprehend. So we need a range of numbers which go from 48 to 20. Well, I do. It kind of depends on what your numbers are. So let's say I've got 48 here, and then I'll have 47, and I'm going to go down in ones and drag it all the way down until I get to 20, because that's my last variable. Okay, so I've just dragged it down. So now what I can do is this. So let's just rearrange these next to the memory address where they're stored, just so that we can kind of see it. So this one is, let's just move main over here for a minute. Just gonna move that out of the way. So this is being stored at number 20, so I'm going to just scroll down here until I get to 20, and there we go. So this is getting stored here, and this is bytes SW. This is an int, so I know that this is taking 4 bytes to store an int. Let's just delete this. So 4 bytes are being used to store this int. So 1, 2, 3, 4. There we go. Let's just colour that in. What's the next one? Oh, it's another byte, which is starting at 24. So let's just scroll down here. Oh, that's working quite well. So this is my next byte, and I know this is going to take 4. This is my next variable, sorry, and I know this is going to take 4 bytes of memory to store. So 1, 2, 3, 4. So that's all the space being taken up by that particular int variable. Let's just colour that in a different colour, just so that we can see it. So now you can start getting a feel for how these things are getting stored. So and just work your way through that, and then you'll be able to answer the questions.